Welcome back to the second episode of Programming Conway's Game of Life from scratch. Currently we're at the stage where the Game of Life looks like this. So we have coded this game window and we have a graphical representation of the game grid, on the simulation grid, and a couple of colored cells. However, there is no backend or no real data backing up that visual representation. So there is no logic behind that. This is basically just a fixed generated image. And well, it's just dummy data which we draw here. And now in this episode, I would like to model the data that we're going to simulate upon. And to do that, we have to somehow model this representation in a data structure in C, or well, it does not even have to be a data structure. This can be a simple matrix. And then we have to read that matrix and draw whatever is present inside that matrix to the screen. And probably we're going to generate a matrix in C and then randomly populate the cells here. So let's do that. And then the next step after that would be to then use the data matrix and based on that matrix compute the next simulation step. And then we can loop over the matrices and calculate the next step all the time, and then we can visualize then we can visualize the ongoing simulation, the game of life. So that is the plan for today. I would like to first define a matrix. Now I'm checking what we actually defined here. We have currently defined as global constants the surface width, the surface height. So this is pure representation, the cell width and the line width. Okay. From these representational constants, we can actually already derive the column count of the cells and the row count, which would be enough to generate a matrix. And I'm thinking whether it makes sense to somehow switch that graphical representation, which we employed as constants here, to a more module-based representation. For example, the matrix that underlies everything. Then from that we derive the graphics. But for simplicity, let's keep it like that. And I would say, let's do the following. Here we draw a couple of cells. We should, somewhere around here, we should define a matrix. A matrix is basically a two-dimensional array, which would look like, let me just look that up again. C, 2D array. Yeah, it looks like this, and as you can see, we have rows and columns here, which we can access through the indices. So we're going to create a matrix like that. We're going to call it the game matrix, and it's going to be do we have columns first and rows second, or rows first and columns second? I actually don't know right now. I think it's rows first. Yeah, it is rows first. So game matrix, row count, and column count. And here we would have to initialize that somehow. Well, okay, what is the row count? First of all, let's clarify that. The row count, integer row count, derives from the surface width and the cell width. So let's divide the surface width by the cell width, and that should give us the row count. And then we get a column. No, bullshit. That's the surface height divided by the cell width. Now remember, the cells are squares, so width is equal to height. And the column count is the surface width of the display divided by the cell width. Okay, like this we get a game matrix. And we could populate it with dummy data, but I'm too lazy to write 100 or hundreds of cell values now manually. So I would rather populate it somehow in a more clever way. So let me just check, is there a code example on how to initialize that? Maybe even initialize it with zeros, well, that would be enough for now. Okay, can I leave that uninitialized? I think it should be populated with zeros then. And if I do... Okay, wait. So... then maybe it makes sense to create a method, initialize game matrix, and it will receive as input a pointer to the game matrix, so it can actually act upon that reference. Then we can define that method up here, initialize game matrix, and it will receive as input an integer pointer. Ooh. How do we properly do that if we have a 2D array? This is not going to be an integer pointer, it's going to be an integer 2D array pointer. Oh my god. This might be wrong, but let me just try it. Game matrix. Okay. I'm not sure if this is a valid type definition here. Array type has incomplete element type integer array. Is this an integer pointer? So basically a pointer to a 2D array? Oh. Oh my god, this looks so wrong. So okay, the pointer is going to be used as follows. We are going to we're going to need the dimensions of that 2D matrix as well. So let's call it dimension rows and columns. And then let's loop over for int I is equal to 0 in small I smaller than the rows. Or what are we looping first? Are we looping over rows or columns first? I don't know. For int I equals 0, I smaller than rows. Then we're going to also loop over for j is equal to 0 over the columns and j plus plus. And we're going to access the game matrix. And I hope I dereferenced this properly here. Maybe we have to dereference the game. Let me do it like this. Game matrix, where we dereference the pointer, so we don't have an address, but actually where we get the value of that reference, or we can write a value into it. And then we're going to access the row I and the column j. And we're going to set the value to either 0 or 1. And I'm thinking whether we can use a random initialization right now already. I think I need standard lib for that, because that contains the random function. So where was I? Okay. Here we can use the random function. And the random function, let's have a look at documentation here. 1 second, rand in C. Returns an integer. From 0 to rand max. So how do we get an integer that is just 0 or 1? We can modulo it by 2, because if the number is divisible by 2, then that means that the modulo will return 0, and else it will return 1. I think that should be it. So that should initialize the game matrix. Maybe something is wrong, but we will see that in a couple of moments. Let's just pass the right parameters into that method. Count. Oh, okay. And then let's compile that. CC we're going to compile game of life using gameoflife.c and this str compilation flags. Something does not work here. What is wrong? Warning, passing argument 3 of initialized game matrix. Incompatible pointer type. Yeah. Okay. Maybe we don't need to pass a pointer here, because this is an array which is in and of itself already a pointer. Let's just try this. Okay, let me just clear the screen and call the compilation again. So we still get a warning that the argument 3 is an incompatible pointer type. Expected int asterisk, but the argument is of type int, size type column count. Let's see if why can't I just supply the matrix like that? Array type has incomplete element type in. Oh my god. Okay. Pass array into method C. Yeah, here the problem is that the method signature already expects a fixed size, which I don't like at all. But here it doesn't. So actually that should work. I'm passing the 2D array game matrix as just like this. Pass array with call by reference. Why does this not work? Here we're defining the game matrix as an uninitialized data type or uninitialized variable. Then we're passing that game matrix into the initialized game matrix function up here. Oh, come on. And here we are dealing with that game matrix, which is a double pointer. I mean, that should work, shouldn't it? That, at least according to my understanding of C, this should work. Passing argument 3 of initialized game matrix from incompatible pointer type. Expected int pointer, but argument is of type int. How to pass a 2D parameter as a function in C. Yeah, that's just what we're doing. The only difference is that the game matrix is not initialized yet. But I don't think that should make a difference. Yeah, just like here. We have rows and columns, then we call a function on that, and the function says it expects an array, okay, of rows and columns. Array has incomplete element type integer array. Okay, that seems to work. But this does not work. According to Stack Overflow, C does not really have multi-dimensional arrays, but there are several ways to simulate them. Aha. The way to pass such arrays to a function depends on the way used to simulate multiple dimensions. Use an array of arrays. This can be only used if your array bounds are fully determined at compile time. Okay. Use a dynamically allocated array of pointers to dynamically allocated arrays. Oh no, we're not going to do that. Pass a 2D array like a 1D array, then use as 2D inside the function. Okay, we already tried that as well. Yeah, we need to provide the address to the first entry as such. And then we're going to initialize the game matrix as what? Okay, right now we're assuming it's just a pointer. Like this. And then we have to access that pointer somehow intelligently. Wow, that is not straightforward, but I think we can use it. So we need to dereference the game matrix, which is now an address as defined in the method signature. Then we have to add the row count on top, multiplied by the counter, of course. And then we have to also add the column count on top of that. And that should actually work. So we dereference that? Yeah, that does not exist. It's bullshit. Rows. The rows and then J. Yeah, okay. So let's see if that compiles. No. Aha, okay. This now compiled, I referenced the first element of the game matrix, like so. It's not really straightforward, to be honest. So I'm not sure if we should take this solution. And here we are writing values into that. Maybe it would make more sense to model the entire thing as a 2D array. No, as a 1-dimensional array. But I would be happy if we can do it like as such. I just can't explain why referencing the address as such is not the same as referencing the first element. Should be the same actually. But yeah. Okay, so now that we have the game matrix initialized, we should be able to somehow visualize that game matrix. So we can actually delete all of the cell drawings here, which we did. And then we can create a new routine, a new method called draw matrix. Or draw game matrix. We're going to draw to the surface, and we're going to draw we're going to draw, of course, rows and columns. So for ease of use, I'm just going to pass that into the method, and then also pass the game matrix first element into it. Then we can create a new method that's going to be called void draw game matrix, and we're going to draw to an STL surface pointer surface, then rows, integer rows and integer columns. And then we will also use the game matrix pointer as in the initialization method. Okay, so how do we draw that game matrix? Actually, we loop over that same matrix as in the initialization matrix, probably. We're going to have to read the values from that matrix, so I guess we can just loop as in the initialization. And we're going to read the values, and then we're going to call the draw grid. No, we're going to call draw cell. In the last episode, we created this draw cell method, which draws a cell at a specific coordinate to the surface. So we're going to call draw cell to the surface at coordinate ij. Aha, okay. And we're going to call this draw cell method only if the value in the matrix is unequal 0. So the values in the game matrix are zeros and ones. And of course, we just want to draw the D1 values. Technically, we can paint both. We can paint the zeros black and the ones white, but we already have a black background, so we don't need to explicitly draw the zeros. Or maybe we should, because this would eliminate the need to erase the white cells later on. Maybe that would make sense. Yeah, that would make sense actually. So let's create a new variable, cell value. The cell value should be 0 or 1. And then we're going to provide that cell value to the draw cell value. And in draw cell, we're going to accept the cell value and we're going to paint a color, which is going to be a UN32 color, and that is equal to cell value. Is it equal to 0? If yes, then we're going to paint color black, which we haven't defined yet. So let's define black 0 0 0 0 0 0 0 0, and that is color black. Color black, and the other value is color white. So if the cell value is 0, we're going to paint black, else we're going to paint white. And then we're going to create a rectangle, and in fill rectangle, we're going to use not the color white constant, but the variable that we just created, this one. Ooh. What did I do? Okay. I know what I did. Let me just fix up my Tmux. Okay, so let's try to compile. And the compilation worked. Let's see what happens if we execute the game of life. Oh, and there's a segmentation fault. Great. So where did I mess up? Do we get any more information? No, we just get segmentation fault. Then I would suggest to, before we draw the game matrix, maybe see if we can even initialize the game matrix. So I'm going to comment that out. Nope. So that is the segmentation fault. It's happening during initialize game matrix. And here we access maybe it's easier to do a 1D game matrix. But actually that feels so wrong. Is that really not a proper 2D structure in C? So let me figure that one out. We determine the game matrix, or we use the game matrix address. Add on top of that the row offset at which we're right now, plus the column offset. And that somehow doesn't work. I will just print something here. Printf at I. So just for debugging purposes, I'm just printing the coordinates, the rows and columns. At row and column. So I want to see where exactly it fails. And then let's put the rows and columns here. Compile that. And let's execute the game of life. Okay. Oh, yeah. We're not accessing any. We're accessing the first row and we're somehow incrementing the columns only. Why is that happening? That's actually quite wrong. Int j is 0. Ah, of course. We have to do j smaller than columns. Oh my god. Sorry if you watch this and you spot that error. This is awkward. And now it's looking a bit better. We're looping over rows and columns, but still get a segmentation fault at column 29 and row 19. It's probably the last column and then last row. So let me just double check that. So I starts at 0 and goes up until the rows count and then increments. And then j starts from 0 and goes up until the columns count and then increments. So, Are rows and columns may be mixed up? This is quite interesting because actually it looks to me as if we were properly looping over this. Huh? Why is there... Ah, of course, yeah, here's this the same error here. Okay, I was just checking one of those methods and calling both of them. Yeah, of course, they have the same error. Yeah, let's just execute that again. Oh, okay, and we have initialized the game of life, but of course something is wrong. Probably the right-hand side of those cells are not initialized because rows and columns are mixed up. So, but why is that? The game matrix, the first array operator here defines the row count. Is that actually true? So, no, maybe not. Maybe this is the column count. And this is the row count. Why? Because in the first element of the matrix should be a row, and it should have separate entries. Well, let me visualize it for you. So the first element of the matrix should be this row right here. And every entry here should reflect a column. So that means if we access here the 0 here, oh, this would be the row count. No, that is right. Let me just... no, that doesn't... No, that's not working properly. Something is off. We initialize the game matrix here. Then we access it through I multiplied by rows plus j, which is good. Then probably something here is wrong here. The column count maybe. Column count is surface width divided by cell width. That is fine. Surface width divided by cell width. I think it makes sense to print out the row and column count here, just to be sure that they are correct. Rows is D, columns is D, new line. Row count, column count. Okay, let's compile and execute, and we have 20 rows and 30 columns, so that is 20 down, 30 to the right. Okay. When we initialize the game matrix, we provide rows and columns. We have row. Let me just print these values here again. Rows is D and columns is D, new line. Rows, columns. Okay, something doesn't work here. Yeah, of course, because I use print and not printf. And it still says 20 rows, 30 columns. Maybe we need to loop over the columns first. How did they do that online? Let me pull up the Stack Overflow here again. Rows, columns. row, column, and then access the value as such. This is quite interesting. What is still wrong here? This is definitely missing 10 cells, which is very suspicious. Initialize game matrix, rows, columns. Let's copy that print statement here as well. Should be the same, right? And is the same. When we're drawing the cell values, is everything okay there? Looks like it. What if we draw a single cell? Draw cell. Oh, come on. Draw cell to the surface at 25, 10. With a value of 1. Yeah, so the cell drawing works. So what the hell is wrong? Drawing cells works, drawing the grid should work as well, because well, it's just a grid and the grid works. Then integer I use 0, I smaller than rows, I plus plus, integer j is 0, j smaller than columns, j plus plus. Am I stupid? I columns plus j. Oh, and I'm doing I rows. Am I? Yes, that is it. But why is that? Then I was completely misunderstanding the logic here. So let me just confirm. I columns multiplied by j. Yeah, that depends on how it is stored. Or how is the data stored? We have a game matrix, which is just one blob of storage. It's a blob of addresses. We're adding on to that. Why do we add the row count, the current row, multiplied by the columns? Let's just see if it works. You can philosophize after that. No. Huh? Rows, columns, rows, columns, columns, columns. Nah, this is way too confusing. I will create a simple two-dimensional array, which is the row count multiplied by the column count, which is the total element count. Then I will provide that array into the function. I'm not going to use any hacks from Stack Overflow now. Then it's going to receive as input the game matrix. Not sure if that is valid. And inside the initialized game matrix, we're going to loop over rows and loop over columns. And the value of the game matrix at the array index number I multiplied. Okay, I would like to, let me just create a new drawing here and do a black background. And yeah, so this is our small matrix. It consists of 3 rows and 3 columns. Now this is going to turn in a 2D model into one vector that's going to consist of nine elements like this. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, you get the point. Can I? Yeah, just ignore the last one. So, where can I change the brush? Doesn't matter. Anyways, that's how we're going to model the 2D matrix. So in the game matrix, we multiply I. No, wait. Let me just do the following. I'll create a black shape box to draw over that. Probably there's a better, cleaner way. But yeah. Okay, so this is now our array. And in our 2D matrix, this right here is row 1. And in the 2D array, this is going to be row 1. Now, this is row 2. And in the 2D array, this is going to be row 2. And same goes for the last row. So we're going to concatenate the rows. Okay, that means we will use as an index the row index plus the column count plus the column number multiplied by I by j. No, wait. The column number wait, okay. This is not straightforward for my brain. Okay, here are the brushes. Okay, this is index 1. This is 2. This is 3. All of this is determined by I. And because we're in row 0, this needs to be offset by 0. So then these are going to be I plus, now we need to somehow find that offset, which is 3. That offset is the row size, no, the column size. Column that's the column size multiplied by, in which row are we right now? In row I. So this must be j. Right, because j is the column iterator. So we do j plus column multiplied by I. J plus columns multiplied by I. And that is equal to random modulo 2. So I will yank that double loop right here and replace the logic as such. And let's see what happens when we compile. What? Huh? I expected everything but not that we have the same issue in this representation. But this is the only thing that is the same, right? This must be it. We pass the x and y coordinates here, and I flip them. Yes, now that is the game of life initialization that is properly done. Okay, still I would like to, well, let's just use the 2D approach and also access the game matrix value here according to our 2D array. I'm also happier with this model because it's something we can think about with our own brains, and it's not a weird hack. The other one is not a weird hack either, but it's a bit above my skill level. So good, that is good. And now what we can do is we can do a game loop, and for every loop iteration we're going to create a new game matrix and then have an ongoing animation. So what I would like to do is a while something, we're going to, so while something is going on, while the simulation ongoing, and that is a new integer, simulation ongoing is equal to 1, so that is true. While the simulation is ongoing, do the following. draw the game matrix, draw the grid, update, and introduce a small delay. Let's just do 1 second. Okay, then peppermint tea. Okay, so, and also I would like this while loop to not be limited by an always valid condition. I would like to be able to interrupt the software and be able to close the window. So we would have to fetch for a close event. So let me just look that up. SDL quit event. And the documentation is here. So that is a quit event, and we somehow need to handle this event. Yeah, we can create an SDL event variable and then poll for an event that has happened. So let's just do that. So there's going to be the SDL event has no value, and then we will where is it? Use SDL poll event to do something. Okay, we're going to poll the event, and that's going to write a value into the event variable. And then we can check if event type is equal to SDL, and then there should be something like a quit event. And if there is a quit event, then we can set the simulation ongoing to false, and that will quit the loop. And I think this should be good. Expected expression before SDL quit event. Maybe, do we have to access the type here? No. Yeah, it was like that. Why is poll event not working? Warning, implicit declaration of SDL poll event, of course, because I have a typo in poll event. Let me fix that. Poll event. Okay. Oop. Can we exit? No, we can't exit. Great. Damn it. How the hell do I exit that? Terminal. Oh my god. And that is exactly the problem I was talking about. If we don't check for events properly, then we can't exit the application. So let me just kill this process that we have running and move back into our code. Oh, now it complains, oh, I was killed. Yeah, of course you were killed because you didn't listen to me. Now, poll event, event type. Should be okay actually. But maybe we have to... Yeah, the SDL quit event has a type SDL quit. If we check the SDL event, the type of that, then we should get an SDL quit event. Let me just look up the poll event. This returns an SDL event. Yep, that is fine. While SDL poll event, poll until all events are handled. Aha, okay, so while the game or the simulation is running, we have to poll all the events. And SDL poll event will return an integer until until it will return 0, and then okay, this is basically saying process events until there are no more events to be processed. So here we do the following. We're polling events, checking the event type, whether the event type is quit, and then we set the simulation ongoing to 0. Should be okay, right? Right? There's a missing bracket. And I guess we can compile and risk restarting the software. And of course it doesn't work again. Oh, but I was able to exit it, so that is nice. Okay, and because we have an SDL delay of 100, we are every quit event takes up to 1 second to be processed. So let me show you. I'm pressing the quit button now. Okay, and it took a while. That is interesting. Okay, but I learned something new today. Oh, that is something new. And then, okay, now we also need to initialize the game matrix inside that loop in order to generate new data over and over again. So let's compile that and have a look, and now we should see an animation. It doesn't make sense, but it is an animation on which we can build the game of life. And yeah, that is already something that is quite cool. I think at this point we can close today's episode, because now we actually have a working animation and a working, well, model. And next time, all we have to do is we have to calculate the correct game matrix based on Conway's Game of Life simulation rules. And if you're interested in that, then stay subscribed and leave a like, also a comment. Please roast me in the comments and tell me everything that I did wrong in this episode, because actually I did a lot of things wrong probably. And I'm looking forward to answering your comments. And yeah, last thing I want to do is let's just remove the or decrease the delay a bit and have a look at a faster animation here. Yeah. So this is quite cool. If you think or if you agree with me, then show some love. Okay, see you in the next episode where we actually implement the simulation logic. Then see you next time. Bye.